Hi, so let's now look at triple integrals in Cartesian coordinates. Okay, and this particular example that we are given, it does not require us changing the order of integration. What I just want to bring to the table is the understanding of how we deal with triple integrals. Of course, it's a similar concept to what we are doing under double integrals and the like, but we'll begin triple integrals from here. Okay, so for this one, we don't really need to change the order of integration. Okay, we don't need to change the order of integration, but of course, we will dedicate a separate video where we talk about changing the order of integration of triple integrals that are given in Cartesian coordinates. Okay, so let's go ahead and work this one out. Okay, so one thing that you're able to observe is that the order is given as dz, dx, dy. So the integrand being a 1 here, uh, we clearly see to say, of course, we are integrating with respect to z firstly. That's our inside integral. Okay, so let's go ahead and do that. So for the outside part, we have like the limit from 0 to the square root of 2. Then this other one is from 0 to 3y. Okay, so if you integrate 1 with respect to z, you're going to get z. Okay, then if you evaluate z from this to that, this can be written in this way. It's more like you're going to say you are moving from 8 minus x squared minus y squared minus the lower limit now is x squared plus 3y squared, like that. So remember now that we no longer have the dz, we just have the dx, dy. Okay, so we can go ahead and simplify this. How is it going to be? So you have to say this is just going to be 8. Okay, then you have minus 8 minus x squared, and distributing that negative there, you're going to have another minus x squared, meaning you have like minus 2x squared. Okay, then the same applies to the to this part that has a y. So you have minus y squared. Distribute this negative inside, you're going to get minus 3y squared. Hence you end up with something like minus 4y squared, like that. Okay, so this ends up to be 0 to square root of 2. So now here, let me not waste time on this part. You observe to say, since this one has become our integrand, you can go ahead and integrate this with respect to what? With respect to x, then evaluate. So when you integrate that with respect to x, you're going to get 8x minus 2 over 3x to the power 3 minus, this will just be 4y squared x. Since 4y squared is a constant, we just add an x there or multiply by x. So evaluate from 0 to 3y, you just remain with dy here. Okay, so what will this become? So one thing that you observe is that 0 won't give you anything. That will be a 0, so no need of focusing on the lower limit, which is 0. Just focus on the upper limit, which is 3y. Okay, so if you plug in 3y where there's x there, you're going to get 20 you're going to get 24y, like that, minus, plug in y where there's x to the power 3 there. Sorry, plug in 3y where there's x to the power 3. You're going to end up with 18 x to the power 3. How I'm getting this is very simple. I've just said 2 over 3. Where there's x there, I plug in 3y to the power 3. You observe to say this is the same as saying 2 over 3 multiplied by 3 to the power 3, okay, multiplied by y to the power 3. 3 to the power 3 is 27. 27 divided by this 3 here, you're going to get a 9. 9 multiplied by 2, that's 18. Then for this part, what do you end up with? If you plug in 3y where there's x here, you're going to have 12 minus 12 y to the power 3. Okay, you have your dy there. And you observe to say this can be simplified. uh, those those two are like terms, and I might have made a mistake there. I wasn't supposed to write y, but I'm not supposed to write x, but I'm supposed to write y to the power 3, like that. Okay, so and you observe to say this is like minus 18 minus 12, that gives us minus 30. So I can just write minus 30 there, minus 30 y to the power 3 dy. Okay, so let's go ahead and do the final integration and evaluation so that we come up with our final answer or solution. Okay, so when you integrate that with respect to y, this is just going to be 12 y squared, because when you add the 1 here, that's like 1 plus 1, that's a 2. Then you do the same here, that's going to be 2. 2 into 24 is a 12. That's where I'm getting it from. Then for this part, you're going to have 30 over 4 multiplied by y to the power 4. Okay, don't forget about the limits. You're evaluating from 0 to the square root of 2. Okay, so plugging in, this will be like 12, and again, once again, I don't have to worry about the 0, so I can just put the square root of 2 squared minus that would be 30 over 4. Then you have like the square root of 2 to the power 4. So the square root of 2 to the power 4 is simply a 4. So observe to say this can cancel out and that can cancel out. So what do you end up with? This becomes like, at this point, the square root of 2 to the power 2, that's a 2. 12 times 2, that's 24, minus, here you have a 30. So this gives you minus 6, and it's actually our final answer for this particular question. So we have concluded to say that this three-point integral that we are given here gives us minus 6 as the solution, and that's how we answer this one.